This is the 2019 NCEA Level 1 Mechanics exam. Question 1. Boat travels across a lake at the start of a walking track. The graph below shows the boat's journey. Describe the motion of the boat during each section of the journey. So just some things to reference. I'll grab my highlighter because you should probably use a highlighter for your exam. It says you can only use pen, but highlight doesn't count. So you've got speed on the y-axis and you've got time on the x-axis. So this is a speed time graph, not a position time graph. So section A, you can see it started with 0 meters per second. After 400 seconds, it was moving at 3 meters per second. So we can say the boat was accelerating in the first what is it, 400 seconds. You could have just said accelerating. Section B, the boat is moving at constant speed. Boat is moving at constant speed. Of, you probably just put in 3 meters per second. And section C, the boat is decelerating, I'm not sure how to spell that, but it doesn't matter. Decelerating, that's really about it. Oh, that'll do. No, I'll put it 400 seconds. It is for 700 to 800 seconds. You don't really need to put that, but I just chucked it in anyway. Right, calculate the acceleration of the boat in the first 400 seconds. So in your formula sheet up here, you have acceleration as change in velocity over change in time. So A equals change in velocity over change in time. How much did our velocity change? This is section 400 seconds, so it's up to here. So I'll just segment this whole thing actually, because these are the 3 sections, and I'll just check an A, B, C for us to see. So it went from 0 to 3 meters per second. So it's 3 divided by, and the time that it took was 400 seconds. So 400, and that equals, grab my calculator, 7.5 times 10 to the negative 3. So I'll write 7.5 times 10 to the negative 3. And it would be fine if you wrote it if you have like another calculator that has 0.0075, and this is, the units are meters per second to the power of 2, or meters per second negative 1. It just means negative 1 just means it's divided by. So I'll just go 7.5 times 10 to the negative 3, but both of these are fine. Right. Next question. Explain the acceleration and the motion of the boat shown in section B of the graph by discussing the horizontal forces acting on the boat. So if you look at section B, it's not accelerating. So if it's not accelerating, because force equals mass times acceleration, if acceleration is 0, the net force is 0, which means the friction force, or the drag from the water, is equal to the thrust force, or whatever you want to call it, of the motors pushing forward. So I'll just pause, write it up, and then fully explain. Right, so I've said in section B the boat is not accelerating, so the acceleration equals 0 meters per second, as the net force, which is this formula here, is equal to mass times acceleration. I've just put MA, but it's mass times acceleration. If the acceleration equals 0, then the net force equals 0, because 0 times anything equals 0. This means the forces are balanced, because the total force is 0, so it means one force is that way, one force is that way, they cancel out, or they add to 0. Where was I? So this means the force is balanced. So the thrust force, which is, I don't know, the motor force, you can call it whatever you want, is equal to the drag force of the water. Right, next question. Show that the total distance travelled by the boat is 1,650 metres. That is literally, so this is a speed time graph. The area under the line gives you the distance. So the area, this area here, if I could shade it in with this pen here roughly, this area here, and this area here. So it's easier to add them A, B, and C separately, because A is a triangle, we need to use half base times height. B is a square, so it's just base times height, and C is another triangle, so it's half base times height. So what we'll just do is we'll just do A is equal to half, I'll go base times height, which it really means is equal to half, what's the base? Base is time, so that is going to be time multiplied by velocity, because that's the height, which is going to be 0.5 times the time was 400 seconds, 400, and it got to 3 meters per second, so that equals 600 meters. So we've got 600 meters. B, section B, I should have put, instead of equals, I should have put dot dot. That's also half base times height, but I'll skip the rest. I'll just go half velocity times time, but it's not, because it's a square. So this is a square, so it's literally just scribble out that half. So that is going to be equal to 3, because the velocity was 3. Yeah, all the way along. It's the height, and 400 to 700 is going to be 1 to 300 seconds. Times 300, and I don't need to use my calculator for that, but you can if you want. That is going to be 900 meters. And then section C is going to be same again. It is a triangle, half base times height. That's actually the other way around. It's height times base, but whatever. I did it right that way. That's just because I'm so used to doing velocity times time. That is 100 seconds, and the height was 3. So it's going to be equal to 0.5 times 3 times 100, and that is going to be equal to 150, because half of 100 is 50, 50 times 3 is 150, so we go section A plus B plus C, I'll chuck some brackets around there, I don't know why, and that is going to be equal to 1650. As you can see, I've done there 1650 meters. Right, so this is, I've just shown you how to do this. When you do this yourself, you should probably annotate. So you should probably say distance of A, distance of B, distance of C, and then just use a trapeze, just use an area under the graph. It's the easiest way to do it for year 11. There are other kinematic equations that you can use, but let's just not worry about that for this level. Just wait until you do it in year 12.